For warm-up, let's calculate and interpret the mean and the standard deviation of x, which is the number of units a random student would take at North Lake Community College. Do it just like we did last chapter. Remember, to receive credit, you have to show your work. So there's the work for the mean, 14.65 hours, and there's the work for the standard deviation, 2.056 hours. Don't forget the units, the hours. Now, if the tuition costs $50 per unit, then how can we calculate the standard deviation and the mean without re-putting everything into the calculator, into the list one again? See if you can do that. Actually, all you have to do is multiply the mean and standard deviation by 50. So the new mean is $732.50, and the new standard deviation for tuition is $102.80. So all you have to do is multiply. Now let's add college fees. There's always a fee. So let's add $100 for each student for the fee. And can you calculate and interpret the mean and standard deviation this way? Again, you don't have to recalculate all the data points. For the mean, all you have to do is add 100 to the quantity of 14.65 times 50, and you get $832.50. For the standard deviation, you don't even have to worry about the 100. Since everyone got $100, it would not affect the deviation from the new mean. Okay, here's the math. If you multiply each value or divide by a random variable b, it multiplies or divides the measures of the mean and the median and the standard deviation and the IQR by b. It does not change the shape. Adding the same number a to each value of the random variable adds to the mean and median, but does not affect the standard deviation or IQR. Once again, it does not change its shape. So, if y equals a plus b times x, the mean of y is equal to a plus b times the mean of x, and the standard deviation of y equals the absolute value of b times the standard deviation of x. Since b could be negative, the standard deviation is always positive. Now you try number 44. It's on the next slide. Read question 44 to yourself and try to work it with your partner. Well, if you get these answers, you're pretty good. Remember, the old mean was 3 million and the old standard deviation was 2.52 million. The new mean, all you have to do is plug in the formula. 0.9 times 3 million minus 0.2 and equals 2.5 million. For the standard deviation, all you have to do is simply multiply times 0.9. Remember, adding things or subtracting things do not affect the standard deviation. Now let's combine random variables. For any two random variables x and y, the expected value, t, which is total, is simply equal to the mean of x plus the mean of y. But unfortunately, you can't add standard deviations. The good news is we can actually add variances. You've been asking how variance is important all year. Well, here you go. You can't add standard deviations, but you can add variances. So the new standard deviation is simply the square of the two variances added together. That's not too bad. One last catch. The two random variables must be independent for this to happen. Here's another example. North Lake also has a downtown campus, downtown Dallas, I guess. So let's go ahead and combine the number of hours for the downtown campus and the regular campus. Let's combine the number of hours in the mean, and also let's combine the standard deviations. So the mean of S is 14.65 plus 15 units, which is 19.65 units. And now for the standard deviation, remember you can't add standard deviations, so you add the variances and then simply take the square of that. Now you have 3.085, so that's a combined standard deviation and the combined mean. Let's put this all together. Go ahead and answer A and B with your partner. Well, how'd you do? Well, for A, all you had to do was multiply the mean by 55 and the standard deviation by 55. And you get $825 for the mean, $126.50 for the standard deviation. For B, that's when you're combining random variables. Once again, adding the means is pretty simple. Just add them. $1,557.50. But for the standard deviation, remember you can't add them, so you square them, get the variances, get 26,570, then take the square of that for the new combined standard deviation. Alright, go ahead and calculate this one. This is a U try. Alright, raise your hand if you got tricked. I bet you did. Remember, the asterisks, X and Y must be independent to find standard deviation. Students who take more classes should use more books. Therefore, that's not independent. Now you can still calculate the mean. 832.50 plus 153 is 985.50, but you just can't calculate the standard deviation. There's a cool formula for doing things if they're not independent, but we'll do that. We'll save that for later. Alright, I won't trick you this time. Let's go ahead and call the main campus T and the downtown campus U, and let's calculate the difference in the tuition charges. So when you do the means, you simply subtract. When you do the standard deviations, do the same thing you did as when you added them. For the mean, you simply subtract 732 minus 825. Since 9250 is negative, this means that the average full-time student at the main campus pays $92 less than the full-time students at the downtown campus. But with standard deviation, you do not subtract. You still add the variances. And so that's $163. Alright, here's the homework for this section. Section 6.2 in your online textbook. Let's get rolling.